We're looking at the issue of identity through time, how objects persist over time, which typically includes changes. And we're looking at the view of Roderick Chisholm. This is from a chapter in the book, Language, Belief, and Metaphysics by Kiefer and Munitz. They're the ones who edited that book. It's a SUNY Press book. And I'm using the article that's been reprinted in Metaphysics, The Big Question, edited by Peter Van Inwagen and Dean Zimmerman. And that is the book that the page numbers are referring to. So the ship of Theseus is a problem where we talk about, and this is going to be simplified, but the idea is, suppose you have a wooden ship that's slowly replaced with aluminum parts. This is obviously Chisholm's revised version of this problem, while a ship is constructed of the old wooden parts. So you have an initial wooden ship, you slowly replace each of these parts, the planks, the wooden planks, with aluminum parts, and then as those are discarded, somebody's collecting them and they make that into a ship. So after that's completed, the question, which is the ship that first set sail, seems to be an interesting question, right? Is it the aluminum one that, has had this consistency back to the ports of setting sail, or is it the wooden one that was reconstructed out of all the parts that was from the ship that originally set sail? Now, you can do this with other objects like a car, where you're replacing a door and a hood and then, larger portions of it, or a computer, where you take out the RAM and replace that, and then maybe replace the hard drive and eventually the processor. And is it the same computer after these parts have been replaced? So that's an interesting question to pursue. And for Chisholm, the lesson from the ship, it goes something like this, okay? When we say of X at one time that it's the same as Y at another time, what we're doing is we are speaking of identity, or using the word same, in a loose and popular sense. That's Chisholm's phrase. In other words, we're not being philosophically strict with our language when we're doing. And it's the loose and popular sense of identity that's at work in the problem of the ship of Theseus. And it's also a loose sense of identity that's at work in problems of parts whole, such as streets or trains. So a train that takes off and then eventually has one of its cars replaced, and so on, or a street where you have the street north of the river and the street south of the river, and maybe it has different characteristics in each of those locations. And so what Chisholm says is, well, we're really not talking about identity in a strict sense. So let's contrast this idea of loose identity and strict identity. So we already said that the ship of Theseus, if we were to say it was the same ship, either ship we identify, it's going to be some kind of loose identity, especially if you took the route of saying it was the aluminum ship, which may have the same cargo and the same captain while, having those individual parts replaced. And it's a loose sense when we talk about trains that run the same route. So this is the same train I was on yesterday. And even though, again, it may have had a car replaced since yesterday. So these things are apparently one and the same, but they've changed an attribute. So we might even talk about a car just being painted, right? Simple as that. It was a blue car and now it's a black car. Is it the same car? Well, Chisholm would say it's the same car in a loose and popular sense. In contrast to this, though, there is something that we could call strict identity. And strict identity always conforms with the principle of the indiscernibility of identicals. The indiscernibility of identicals, not to be confused with the identity of indiscernibles, which is a different principle, is this: if X and Y are identical, then X and Y have all properties in common. And we could construct a formulation for this using logical notation for every X and every Y. If X is identical with Y, then every property P that X has is a property that Y has. So if X has property P, then Y has property P. And that's an if and only if. So every property that Y has is a property that X has. And so you can think of it again in the way that we just wrote it in natural language. If X and Y are identical, then X and Y have all properties in common. So that is a sense of strict identity. So now when we turn to an example here of how this loose identity works and what kinds of problems you might come up with. And I'm taking this from page 175 in the reprint that's in Metaphysics, the Big Question. And we're looking at, so suppose you have a very, very simple ship. Somehow it's composed of only two parts. And on Monday, those two parts are A and B. Then Tuesday, you swap out A for C. And so you have this ship that is composed of B and C. Now, Wednesday, let's suppose you do something a little different and you take B and you add D to it. And you take part C and you add E to it. So now we have this similar issue as the ship of Theseus. And then we could do that again, say on Thursday, where we have D and F and E and G. Now notice the two ships we have on Thursday have none of the same parts. Neither one of them have the same parts as the ship we started with on Monday. So what Chisholm calls this is a non-intactly persisting temporal object. So it's persisting over time. A ship is persisting over time. And let's take the initial branch on the left. So we have AB, BC, BD, and DF. That's persisting over time, but non-intactly. In other words, the parts aren't always the same. However, if we're considering part B, B is an intactly persisting temporal object. That is, all parts of B are the same at all times. It's just that one part, part B. So B on Monday is identical in that strict sense, the one that conforms with the indiscernibility of identicals, as B on Wednesday. It is one and the same thing, right? Every property that B had intrinsically on Monday is a property that B has on Wednesday. Now, you take this idea, so we have you could call Monday and Tuesday the stem of the ship, and I didn't center it up well, but you could see how it could form an inverted Y. And if we think of it that way, how many ships are there? Well, one way to count them would be there are 6 non-intactly persisting temporal objects in this problem with only 2 parts. What are we counting as 6? Well, you got the whole Y. You could count that as a ship. You have the stem. That could be a ship. You have the left side of once it branches, and then you have the stem in the left side once it branches, the stem in the right side once it branches, and of course just the right side after it branches, and you have just the stem. And so you can identify any of those things as a ship. Now, here comes a challenge. Suppose DF collides with EG, and both are about to sink. Now, there was a captain who committed himself to AB, the initial ship. Said, I will go down with the ship. And suppose that captain is on either DF or EG, it doesn't matter. With which ship should the captain go down? Right? That seems to be a legitimate question. He pledged allegiance to the ship, but it's not easy to tell which ship he should be committed to if they've collided and they're both about to sink. So how do we investigate this? Well, we could speak of the momentary parts as constituting the whole ship. So we would say that, for example, AB and BC constitute the stem. AB is part of the stem on Monday, BC is part of the stem on Tuesday. So together they constitute the stem. So AB isn't the stem itself, it only constitutes it at a particular time, that is Monday. All right, that's one way of thinking about it. Or we could say that Y constitutes the same ship now that X did then if Y evolved from X. And we could put it that way. And then we would need to, of course, specify what we mean by evolved from. And maybe that would make use of the ideas of having the same schedule or covering the same route. Those kinds of things, where maybe parts were replaced and put back and what have you during that time. But then how many ships were involved in our inverted Y-shaped description? Were there 6 ships? Were there 2 ships, the stem in the one branch and the stem in another branch? Were there 11 ships where we're counting stems and individual days, AB and BC, and then the stem AB and BC, that would be 3, and then so on and so on. Maybe there are only 3 ships, the branch, 2 branches after it divides, and the stem. You know, how many ships were involved in this description? Well, as far as Chisholm goes, this is a problem that conventions can solve. So if we say that Y constitutes the same ship now that X did previously, then this does not imply that Y is identical with X in that strict sense. So Y wouldn't be strictly identical with X. It would not adhere to the principle of the indiscernibility of identicals. So what Chisholm says in this case is that the answers to the kinds of questions being raised could be resolved in a couple different ways. I mean, it could be resolved by, say, dictionary writers who declare what a ship is. You know, they say, this is what a ship is. And then if you follow that definition, you identify what ship. It could be solved by a jury or a court. So the captain who went down with one ship, and then they say, well, he, pledged to go down with AB, but he went down with EG. Did he fulfill his duty? And the jury or the court could resolve that idea. Now, that would be, of course, more relevant for issues like cars, where parts were being discarded, and then somebody took the parts and built a new car. And the initial owner may declare ownership of the new car that was built from the old parts, but the initial owner might still claim ownership of the car that he still maintains with the new parts. So you have to have a court sort all of this out. And Chisholm says that, conventions, whatever the social interests are, could be used in either case. We just could appeal to social conventions. It's not that challenging of a philosophical problem in that sense. However, certainly some philosophical issues remain. So in order to have questions of persistence over time, Chisholm says there have to be some things that exist by intact persistence, in the strict sense of persistence. So in the example we used, part B would be one of those things that strictly existed over time, or part C, or any of the other parts. Persistence in a loose and popular sense presupposes then persistence in the, sorry about the typo, in the strict and philosophical sense. So we have the concerns that can be resolved by conventions. They only arise if you do have something that's strictly persisting over time. So in other words, you can't even have the conventional or the problems that are addressed by convention without addressing some of these philosophical issues that don't rely on convention. So strictly speaking, again, the indiscernibility of identicals must hold across time, says Chisholm. Now, this is a view that David Lewis is going to agree with as well. Others are going to disagree with that, and they'll point to their various arguments and reasoning. But Chisholm is what we call a mereological essentialist. So let's be clear what we mean when we say mereological essentialism. By the way, mereology is the study of parts and wholes and this kind of very question that we've been exploring. So Chisholm's a mereological essentialist. And what he means by that is strict and literal diachronic identity, identity over time, always involves intactly persisting objects. It never involves replacement of parts. And if you're going to talk about identity in the strict sense, you have to have exactly the same parts. Now, that's fine until we start thinking about persons. So when we say of a person A at one time, that A is the same as B at another time, we speak of identical in a strict and philosophical sense. Don't we? Doesn't that seem to be the case? And when we have this kind of discussion, when I say that I broke my wrist many years ago, isn't it true that it's me? It is really me who had a broken wrist. I'm the one who experienced the pain. It seems that that's the case. And Chisholm, in fact, affirms that that's a case, but this might seem a little bit odd. So consider these three photos. I claim they are all photos of me. On the left, 1984, when my friends called me Dr. G. In the middle, 2002, when I was called Dr. Pettit. And of course, I maintained that name in 2018. But I think you can see by the hair alone the significant differences that I have. So more hair on my chin, less hair on the top of my head as we go through time. And by the way, as I am making this video, I have aged even more since then, but I guess that's not really a big concern. Just forget that I said it. All right, two puzzles for persons remain then. These cases that Chisholm identifies, Chisholm suggests there are puzzle cases to be worried about, to address. One of these cases is just to consider, suppose you have a very expensive operation that you have to undergo, but the expense is all related to the anesthesia, anesthesiologist and the anesthetic being used. And so they say, well, what we could do is do it without anesthetic. We just strap you down and make sure you don't move. And then we'll give you amnesia pills afterwards so that you forget the operation. Would you take this option? You could save thousands of dollars and you don't remember the pain. Well, that's one way of thinking about it. Would it be you experiencing the pain if you don't even remember experiencing the pain? This is an issue that Locke addressed, and he had his own answer to that these memories and continuity of memories are very important. Or what about a more challenging, possibly more challenging case of fission for a person? So the idea here is that a person can survive without a large portion of their brain. Maybe you could even separate. You could say if a person had half their brain destroyed or removed for whatever reason, but they continued to exist, they seem to be the same person. But what if you were able to take half the brain out of somebody, put it in the shell of a body of someone with no brain, and both of the resultants seem to be persons, and both maybe have comparable memories? So who's the same person as the one prior to fission? This is a more challenging case. Now, Chisholm does not give a complete answer in his work that we've been talking about. He does argue that strict identity has to apply in cases involving people. It has to apply. But if that's the case, we're going to need to address some more concerns that are raised here. And so we're going to need to consider a different article by Chisholm where he does address these problems when we look at personal identity over time from Chisholm's perspective and how he resolves these issues.